Good day viewers, here welcome back to my channel. Today we're going to learn how to apply the Demoivre's theorem in solving this type of problem. Okay, now we have if x plus 1 over s is equal to negative 1, x raised to power 333 minus 1 over x raised to power 333 is equal to dash. Whenever this expression is in this form, having this negative sign, it is likely to have more than one value. Okay, so because of this, we're going to compute the value of x minus 1 over x. Okay, remember we're asked not to find the values of x in this case. Okay, so now I have x plus 1 over x 2 squared is equal to negative 1 squared. Okay, now from here I'm going to use the algebraic identity that a plus b squared is the same as a minus b squared, plus 4ab. Okay, so I'm going to use the above idea here. So using the above idea, so the left hand side will be x minus 1 over x squared, then plus 4 is equal to 1. Okay, now from here subtracting 4 from both sides, we get x minus 1 over x squared is equal to negative 3. Now taking root of both sides, so we arrive at x minus 1 over x is equal to plus or minus square root of negative 3, and this is equal to plus or minus I root 3. Okay, now what is our next step? Okay, now let us try to recall that x raised to n minus 1 over x raised to n is equal to 2i sine of n theta. Okay, in this case the power of x here is 1 and this is 1. Okay, so we have here x minus 1 over x is equal to, we're taking n as 1, so 2i sine theta. Our major task here is to find the value of theta. Okay, so from here we replace x minus 1 over s with either positive I root 3 or negative I root 3. Okay, now taking the positive I root 3, so we have I root 3 is equal to 2i sine of theta. Okay, now dividing both sides by 2i and here by 2i, 2i cancel 2i here and I cancel I here, so we have sine theta is equal to square root of 3 all over 2, and taking the sine inverse, so we have theta is equal to sine inverse of square root of 3 over 2, and this is equal to pi all over 3. Okay, is equal to pi all over 3. So our next step, so we're taking the negative I root 3, so we have negative I root 3 is equal to 2i sine of theta, so dividing both sides by 2i over 2i, so 2i get cancelled here and I get cancelled here, so actually we're having here theta is equal to the sine inverse of square root of 3 all over 2. Remember this function is odd, so this is equal to negative pi all over 3. Okay, so we can easily compute the value of x to the power 333 minus 1 over x to the power 333, and we're going to do this as follows. Okay, now we have here x raised to 333 minus 1 over x raised to 333 to be equal to 2i sine, here power of x here is 333, so we have 333 times theta is equal to pi all over 3, so we're taking the first positive value of theta, and this is equal to 2i sine of 3 divides, so we have 111 pi, and this is equal to 0. So now the next value, so we have x raised to 333 minus 1 over x raised to 333 is also equal to 2i sine of 333 times negative pi all over 3. Okay, and this is equal to 2i sine of negative 111 pi, and this is equal to 0. So we have come to the end of today's video on how to apply the Demoivre's theorem that x raised to 333 minus 1 over x raised to 333 is equal to 0 if x plus 1 over x is equal to -1. Thank you for viewing, and please make sure you subscribe to my YouTube channel for more interesting videos.